மாணவர்களின் சிந்தனைகளை வடிவமைக்க Institutions மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS Institutions மாணவர்களை போற்றும் SNS Institutions கோவை.
Everyone, this is R.Vijayakumar, Assistant Professor, Department of Electrical and Electronics Engineering from SNS College of Technology. So this topic comes under Renewable Energy Technology and Unit number 1. So the topic number 3, so navigating the future, understanding renewable energy. So why the global is focusing on a renewable energy? Why we are more impact or a more concentration about towards the renewable energy? Even though we have a non-renewable energy, but we are focusing on a renewable energy. And also the renewable energy is also called as a green energy or clean energy or advanced energy technologies. Because global energy demand is surging, driving the urgent need for a clean alternatives. Renewable sources accounted for an impressive 83% of new power capacity in 2022 per IRENA. Our global is to decarbonize energy systems and significantly reduce climate impact. This presentation explores various renewable energy types and their inherent limitations. Okay, so first one, we are going for a solar power. This will be abundant and intermediate. So why we focusing on a solar power? So many developing countries, developed countries, so all are focusing on a solar power. So harnessing sunlight, so that means the solar power converts sunlight into electricity using photovoltaic panels or concentrated solar power systems. It experienced rapid growth, contributing 34% of new renewable capacity in 2022. And then key limitations, solar power's intermittency is a major challenge. It produces no power at night or on cloudy days. This necessitates robust energy storage solutions. Large solar farms also require significant land, about 5 to 10 acres per megawatt. Furthermore, material sourcing for panels like silicon and their eventual disposal pose environmental concerns, with 78 million tons of panel waste projected by 2050. So solar power, it has a double-sided knife. One side it may use as a advantages, at the same time it will be gives us some kind of disadvantages. So next one, we will move for a wind power. So that will be a clean yet variable. So energy conservation wise, the wind power converts kinetic energy from wind into electricity using large turbines. It's a significant contributor, generating over 7% of global electricity. And variability challenges, wind strength varies, leading to intermittency that requires sophisticated grid balancing. And concerns also include visual and noise impact on communities. Wildlife, particularly birds, bats, face mortality risk. For example, 140,000 to 5 lakh birds annually in the US. Consistent strong winds are essential, often limiting viable locations to remote areas. And third one, we will move on a hydroelectric power. It will be reliable but site specific. We can't install in any places. So that means harnessing water flow. Hydroelectric power utilized in the flowing water, often through dams or run-off rivers, to spin turbines. It is the largest global renewable sources, accounting for a 16% of the total power. And also the construction costs, upfront construction costs are exponentially high. For instance, the Grand Clue Dam cost $6.3 billion adjusted for inflation. And also the environmental and drought risks. So dams disputes the river ecosystems and block fish migrations. Hydroelectric output is also vulnerable to droughts, as seen as California, where hydro generation dropped 40% in 21-22. Suitable geographic sites for large-scale projects are limited. And geothermal energy, it will be a constant, and also it will be a location dependent. And utilize earth's heat. So with the help of Thermal energy harnesses the Earth's internal heat from volcanic activity or hot rock formations. It provides continuous baseload power, often with over 90% capacity factors operating 24 into 7. And geographic limitations, its economic viability is confined to technologically active zones. Initial exploration and well drilling are expensive, costing $2 to $7 million per well. There's minor risk of induced seismicity causing small tremors. So that will be a dangerous one. And bioenergy, renewable with sustainable challenges. First one, diverse applications. Bioenergy is derived from organic matter like crops, wastes, or forest residues. It offers diverse applications including electricity, heat, and biofuels for transportations. Land use competitions. And a major limitation is land use competitions, leading to food versus fuel debates, such as with corn ethanol, burning biomass can release CO2 and particulates. It will be carbon. And water scarcity. So growing dedicated energy crops is water intensive. There are significant sustainability. And finally, addressing the limitations, innovation and integrations. So first one is the energy storage solutions and grid modernization and technological advancement. So from this conclude that a path to sustainable future, 83% new capacity renewable contributed 83% of new power capacity in 2022. And also the annual investment, transition needs $4 trillion annually in a clean energy by 2030 per IEA. And also the cost reduction, lithium ion batteries costs are down 89% since 2010. So renewables are essential for a global decarbonization goals. No single perfect solution exists. Each source has unique strengths and weaknesses. Overcoming limitations require continued R&D, infrastructure investment, and policy support. The future is a diversified, resilient, and interconnected clean energy grid. So thank you for watching. We will see you on our next topic in our next class.